Hi everyone, my name is ChatGPT. Oh no, wrong slide. My name's Dale Smith. I'm a lead cloud engineer at Catalyst Cloud, and I want to talk to you about rebuilding our managed K8s service using Cluster API. So I want to celebrate a specific part of this. It's way too big for a 6-minute talk, but I want to celebrate a specific part of this, which is something that a couple of people have touched on, which is Kubernetes controllers and reconciliation loops. But first, I want to tell you about our managed K8s service and sort of what makes one up and what we used to have. So this is OpenStack Magnum. This is the service that provides to our customers a REST API. So they can say, hey, make me a cluster that looks like this, scale that cluster up, delete that cluster, or upgrade that cluster to a new K8s version. And what we used to have is a driver sitting in there, which is a heat driver. Heat is an OpenStack product, but if you're familiar with AWS, think CloudFormation, and it's pretty similar. And what that does is the heat driver in Magnum, once it is asked to make a cluster, it'll go ahead and drop a whole massive template into Heat to say, make a cluster. It looks like this. Here's a template. Here's all the shell scripts to make all the services. Here's all the manifests to drop into this. And it'll build a bunch of nodes and a bunch of control plane things. There's a few problems that we were looking to solve for this. A couple of them are, we've got a bunch of scripts and manifests sitting in here, and we want to support about at least 3 Kubernetes versions at once. Generally, there's 5 because we've got much older ones and they're quite long-lived. So once we push a script into Heat, it needs to know how to do everything for the life cycle of that cluster, which is a bit tricky when you start that cluster at 123 and now you're at 127. So upgrades are difficult, and retries are quite hard, and surfacing errors are quite difficult. So if Heat gets a single API error, and we have many 9s of uptime, but one API error might mean your whole cluster just stops and you have to start that one again. Or retry in Heat, and surfacing errors was also a problem. So there's got to be a better way. And bringing this back to Kubernetes, we're going to start talking about a really simple couple of things that we've talked about earlier with Caleb's talk mostly. And I want to talk about pods, replica sets, and deployments, which you've all used a whole lot. Pods tell you how to run. They define how to run a container and what a good, healthy container looks like. A deployment says, here's a pod template and run this many replicas of it, and here's how you roll it out. And when you update that pod template, it'll make a new replica set, and it'll scale this one up, and it'll scale this one down for you. So it's got this really nice set of controllers that work on this replica set, reading the desired state of the world, reading the actual state of the world. Oh, this replica set is now 2 because it's going down. So that controller kicks in and terminates one of those pods. Where's that button? Hiding. So we found a project called Cluster API. I was actually introduced to this in about 2019 at a KubeCon. But for the last year, we've been picking up this Cluster API and working with it. And this is a really similar concept to the previous slide. Cluster API gives us, in Kubernetes, CRDs for machines. So we actually have a machine object, and it knows how to create a VM, and it knows how to get the bootstrap data to build a control plane node or a worker node and join a cluster. And a machine set knows how many replicas you want, and it will work with a controller manager to scale up however many machines you want. And you've got this machine deployment. There's a lot more resources in Cluster API than this, but these are the main ones, and these are the cloud native concepts that we're going towards. So back to Magnum itself, we've got this API that we've got a lot of customers with tooling and OpenStack tooling that interface is quite stable, and we like that. So we worked with upstream people, Stack HPC primarily, and developed a Cluster API driver so that you can ask Magnum, make me a cluster, and now it doesn't make it in a Heat template format. It now knows how to drive a Kubernetes cluster and put resources in. So now you've got a machine deployment, a machine set, a machine and a machine and a machine, and you've got a K8s cluster with control plane, nodes, load balancers, networks, and these are all done declaratively with reconciliation loops. And that's my celebration today. Yeah! So we're still, we've gone live with this. This is available now, and we're contributing upstream to these projects: Image Builder, Cluster API, OpenStack, OpenStack Magnum drivers, and OpenStack Magnum itself. I'm a core reviewer of OpenStack Magnum. And in case you thought this might not be relevant to you, these are all the other infrastructure providers, not just OpenStack, for Cluster API. So if you want to get involved, or you're like, hey, I might build a Kubernetes cluster with Kubernetes, and you're using those clouds, which is most of them, there you go. That's our journey. Oh yeah, done. Thank you.